All right. Well, thank you so much, Alvin and Shaw, for coordinating this, and excited to have the chance to present today. And so my colleague Joe Amlung, unfortunately, is on leave right now. We didn't know that when we scheduled this, so it'll be just me today presenting. And my video is not working for some reason today, so I'll just be on audio. But please feel free to jump in the chat or just go off mute, and if you have questions or comments during the presentation. Again, my name is John Payne. I'm the director for the Open Concept Lab, which is an open source terminology service. We've been actively involved in the OpenHIE community since the beginning of that community. I've had the opportunity to meet many people who are on this call, so great to get to connect with you again. In my work, have often been supporting countries and implementing partners in the design and implementation of terminology approaches and terminology services specifically. And so today we're going to kind of talk about some of what we've learned over the years, give you a bit of an introduction to how we think about terminology and terminology services and digital health projects. And then we'll also walk you through some of the specific kind of approaches that the Open Concept Lab as a reference implementation for terminology services approaches this. So many of you are already familiar with OpenHIE, and OpenHIE is an architecture specification that defines behaviors for components that are foundational to health information exchange. And so terminology services is one of the key components in this type of health information architecture. And so I imagine for most of you, you're on this call because you're familiar with this architecture, with the OpenHIE community and with the approaches. And so the OpenHIE architecture provides kind of a high level description of the behavior of this component. And so today I want to kind of review what that is and then go several levels deeper into some of the underlying standards for how they talk about the behavior of this component and how you can create value out of it in your implementations. And so again, the three kind of topics that we want to cover is terminology services. What's a maturity pathway that we can think about for what this looks like in implementations? And then what is the Open Concept Lab's approach and its role in this space as an open source terminology management service? So to start, terminology and terminology services. So terminology is a massive topic. We're not going to cover a lot of that today, but just so we have some common language here, terminologies are the language, it's the content. There's plenty of examples in the world. Many of these are open and free to access. Many of them are licensed and used for very specialized use cases. So I just put a few examples here for that we can refer back to during this conversation. So if you were to talk about drugs, like the WHO provides one standard for this, the WHO ATC, and then there's some country-specific versions of this, like RX norm, that if you need a specific code for a drug, you could reference these. For the SNOMED is a popular vocabulary that covers pretty much all of the healthcare domain, and there's a free edition of that, SNOMED GPS. There's also SNOMED IPS, and these are both free, but then there's a licensed version of that, SNOMED CT. For diagnoses, there's ICD-10 and 11. There's a US-centric or specific extension of this called ICD-10-CM. Many countries have extensions like this of ICD-10 and SNOMED and of other vocabularies to capture some of their specialized requirements. There's another category called interface terminologies, and this is how you might because reference vocabularies are often hard to use for data capture at the point of care to capture the granularity of what is of the encounter. And so an interface terminology is designed specifically to support capturing that level of granularity and specificity that you need at the point of care, but without you having to understand how to do post-coordination of codes from a reference vocabulary. So the list goes on here to procedures and labs. This is a small sample of domains and terminologies or vocabularies that are available. There's a much larger list that the OpenHIE and others could refer you to. What I would like to direct you to is if you're interested in diving into terminology specifically, OpenHIE Academy is a free online resource that offers these 6 courses that are specific to different terminologies that would give you a primer and how to think about them, what are the different types, different categories, and even some examples of implementation of these. And so it's an excellent resource. There's a lot of other courses available on OpenHIE Academy as well, but this is where I would start. So today what I want to do though is let's assume we have some baseline of terminology here, and we want to talk about how do we actually use it? How do we make create value in our implementations by leveraging terminology? And so to start, I want to distinguish between these two. So terminology is the content, it's the language, it's a set of definitions or designations that are systematically managed and curated. And we just talked about several examples like LOINC and ICD and SNOMED, and there are many, many more available in the world. So terminology services, though, that is the software or a set of capabilities that you want to make available in your enterprise or in your HIE, and that provides your terminology content in useful ways and standards-based representations to your HIE. And there are some examples of the software that are available to do this. So Open Concept Lab, the product that I direct, is one of these. Apollon DTS is the distributed terminology server, is an excellent product. Onto server is another that I think some in the AHIN community I know are very familiar with. So these are all examples of that, of a software that makes these capabilities available to your HIE. So terminology services, there are a number of specifications or standards that we can refer to to understand better, how should this behave in your HIE, and how could you start to think about using it. So we've already talked about OpenHIE and the architecture specification. It starts with a high-level description of some of these behaviors, and so we'll go into each of these in a minute. The second that I like to refer to is IHEs, sharing value sets, codes, and maps, the SVCM profile. And so a profile is a description of the use of the underlying standards within a particular use case. And so this is a IHE profile that I helped a co-author that describes how do you think about the underlying standards like FHIR to describe a terminology consumer and a terminology repository within a healthcare use case. And then finally, FHIR is the primary underlying standard that we then reference for describing the terminology behavior. So we'll take a closer look at each of these three and start with that so that we all have kind of a common understanding of how do these the components behave. So let's start then with OpenHIE's architecture spec. So the OpenHIE architecture specification describes a terminology service as one of the registry services. These registry services, if you are setting up an HIE, there's a lot of metadata that you must rely on in order to enable different data exchange transactions. So the terminology service really describes the what of those transactions. So what is the procedure? What is the drug? What was the diagnosis? What was the test or the test result? So the terminology service then gets provides, through a number of different capabilities, provides these terminologies that have been loaded into it to the HIE, and can do that through a number of API-based integrations. And so this specification, is available here. I provided links to everything. I wanted this slide deck to be a resource. We'll make sure that it's made available to everybody afterwards, so you can follow up on all of these. So what are those behaviors then that a terminology service makes available to an HIE? So at a high level, there are a number of questions that you might want to ask about your codes and definitions and mappings. And so what are some examples of that? So first you could say, I know ICD-10 is used as a code system for diagnoses. Is that available in this architecture in my HIE? And so that query code system is the first. A code validation is a specific code available in a code system, or a lookup. What are the properties of this code in a particular code system? Code translation is, what is the standard code, like a link code, for this local code that I have in my patient record, such as a CBC code from a particular facility. And then we have some value set operations, and these are, is there a set of codes described for a particular domain or use case, such as maternal health value set? And then I'd like to retrieve those specific codes, that value set. So this is called value set resolution. So in general, these are some of the primary capabilities that a terminology service provides to the HIE. And so the specification for OpenHIE then will describe each of these as workflows, and then defines a set of functional and non-functional requirements on top of this. This is a great place to start if you're thinking about, how do I start to incorporate a terminology service into my architecture? What capabilities could it provide to other architectural components? This is where you begin. But it doesn't go quite deep enough. And especially if you're trying to think about, we're trying to set up that component, and we're beginning to integrate with that component. And so that's where we start to look at some of the other standards. So let's look now at IHE's sharing value sets, codes, and maps. So this is the SVCM profile. So an IHE profile, these profiles are not standards themselves. They describe how do you pick the different parts of underlying standards and apply that to a particular use case. And so this SVCM profile is one of the technical infrastructure use cases. So the use case here is the sharing of terminology content. And each of these profiles has to describe an actor and some transactions. And so in this case, we have two actors: a terminology repository. This is your terminology service, and then the terminology consumer. So this is really any other component in your HIE or point of service application. So something that could be on the other side of your mediator, your interoperability layer. And so the transactions that are described in this profile line up very nicely with how OpenHIE and the architecture spec talk about this. There's the discovery transaction, so querying code systems, value sets, and concept maps. So these line up exactly with the OpenHIE. And then there are the operations. So expanding a value set. I want to retrieve the contents of a value set, or look up or validate a specific code, and then translate a code. So the SVCM profile, one nice thing that it does is it says, it makes some choices about what's required, what's optional for each of these actors. And so you can see that here. Again, I provided links to all of these so you can follow up. So finally, we get then to the underlying standard itself. So this is FHIR. So FHIR, there are other standards that talk about how a terminology service should behave. Some older standards, such as CTS2, but we're the kind of the modern standard for and preferred one in projects, contemporary projects today is FHIR. And so and again, this isn't meant to be a primer on FHIR. We're just going to talk about the terminology module specifically. So FHIR does describe, does carve out a space for terminology. That there are a number of resources, and that's what's on the visual diagram here on the right. And then there are a number of operations. And then there's also an additional specification just for the server. So if you're a server that is not trying to provide general purpose FHIR capabilities such as Happy FHIR, but you're specifically focused on providing terminology services, then there's some additional requirements on top of these. So FHIR describes a few building blocks, and so I think of these as this is the content of terminology, and so we're familiar with terminology code systems and like LOINC and ICD-10. But to make terminology useful, you need to build a few more constructs on top of these reference vocabularies. And so this is one thing that FHIR does well. So what are these content building blocks? So at the lowest level, we have a concept. This is a code and a definition. This is a specific, any clinical concept that you could think of is probably defined out there. So this is something like LOINC 8060, it's manual count of white blood cells and cerebral spinal fluid specimen. So that's your kind of atomic lowest level idea here. And so a code system then is you're bringing a set of these together that have been formally defined. So this is ICD-10 and LOINC, SNOMED, but also a lot of administrative stuff as well. So it could be a really small code set like HL7's administrative gender, and there's just a few codes in that. And so not all of them have to be a large code set like this. Like these reference vocabularies. So then we get to value set. So a value set is a set of codes that are already defined in other code systems. So a value set is how you pick and choose from SNOMED and LOINC and ICD-10 for our particular context. And that could be something simple like the codes in a drop down on a clinical encounter form, or domain or topically focused, like the example here, LOINC codes for cholesterol. And you really could define these in any way that you need. And these can be simple, like simply a list of codes, or it can be really complicated, such as a set of rules for inclusion that must be evaluated. And this is where a lot of the complexity of a terminology server comes in, is the ability to evaluate these rules for value set generation. And that's called expansion. Value set expansion is how you do that. And then finally, a concept map. So a concept map defines relationships between codes from different code systems. So this is a really important feature of this. So there are some concept maps that are made available and curated globally, like between different reference vocabularies. So if you needed to map between LOINC and SNOMED, fortunately that's already been done. And so you could translate between LOINC and SNOMED using mappings that are already made available in the world. But you often need to author your own concept maps as well between, for example, a local code system at a particular facility, or a delivery network, or a hospital, or maybe a particular software application, and the formally endorsed codes in the national HIE. And if you have this concept map available, that enables you to do to automate some types of translations between those codes. And so that's really why we have these building blocks, these constructs, because if you have these content building blocks available in a terminology service that's hosted in your HIE. It enables you to perform certain operations or transactions. So what are those transactions now? So FHIR describes a pretty small set of operations that you can perform on each of these resources. So a code system lets you do a lookup. This is what we talked about before. I'm looking at our particular code. Give me its full definition and all of the properties available for that. That's what lookup does. Validate code just says, is this part of my code system or not? And the same is true with value set. You can validate, is this code a member of this value set? And expansion is what we talked about, is how you evaluate the rules up for inclusion in a value set and actually retrieve all of those codes. And then concept map lets you do translations. And there are a couple more, subsumes and closure, that are a little less commonly used. They're not part of, for example, they're not profiled in SVCM in that IHE profile, but they're still important. So this is the kind of the first section where I described the three different standards, or two different standards and a profile that define what is the behavior of a terminology service, what underlying standards is it built on top of, and how does it interact with other architectural components based on the OpenHIE architecture specification. So this has been, the deep technical dive. So now I want to talk about more the application of this. So if we have a terminology service with these capabilities, and how do you start to make use of that in your projects? All right, so where I like to start is, so we, as in the OpenHIE community, I'm the co-chair for the terminology service sub-community, and an affiliate with Regenstrief Institute. And with Regenstrief, led a project to support the country of Ethiopia to establish a national health data dictionary. And there are existing frameworks to help you think about, if I've got an HIE and we're already performing data exchange transactions, how do I think about increasingly sophisticated ways of leveraging terminology for transactional support in my HIE? So some of those frameworks already exist. What we didn't have is frameworks that described, well, what does it look like if a country is just starting to set up an HIE? What if we're still beginning to develop some coordination and governance around our terminology approach within our health system? And so that's where this maturity model really shines. So we developed this based on projects that we were seeing in Ethiopia and Kenya and elsewhere, to support that process of how do we get to the stage where there's an active HIE that's leveraging a terminology service. So at the beginning here, we'd start with nascent, where there's no centrally defined content or governance. And then the next level is emerging, where there's some centrally defined content published usually in non-standard formats, and governance is just beginning to develop around this. That's where a lot of countries are that we're working with in a lot of our global health projects. And so what we're seeing is that this step then to the next level of a shared electronic reference can be quite a leap. And so what's that next level? The shared electronic reference would be where you have a central resource. There's a central authority for how do I identify or find data standards that have been endorsed for our health system, and how could I access them in a structured and electronic formats, and hopefully standards-based formats as well. And so that climb is steep because it requires a different way of doing business. It requires, like we said, governance. There's got to be standard operating procedures. Like, how do we make this content available? What happens when it's updated? What happens when we're receiving requests because we don't have terms to describe an emerging subspecialty for oncology care at our hospital. And so there's a big leap here. And so a lot of the projects that we support are trying to bridge that gap from emerging to shared electronic reference. So what's next? That'd be digital subscription. So this would be where point of care systems are beginning to leverage that shared electronic reference directly and electronically to bring down up-to-date codes into their local data dictionaries. And then data exchange is where you're actually beginning to do transactional use of a terminology service. So let's go into a couple examples for each of these. And so I like to think of this as you could apply this maturity model to the entire health system, but you can also think about it at a project level. And so when we're speaking with governments, we like to think about let's identify an example milestone or implementation example for a project at each of these levels, because probably all three of them are going to exist simultaneously in your health system. And these could be models that other projects could follow for how could they go or climb from the shared electronic reference level to digital subscription, or climb from digital subscription to data exchange. So let's start with the shared electronic reference. So the leading example of this in the world right now is in sub-Saharan Africa. It's the Kenyan National Health Terminology Service. So this is an example of a national terminology service implementation that is aiming to set up projects and examples at all three levels of maturity, and right now has already deployed a shared electronic reference as a public portal to access formally endorsed standards in the health system. And so the stated goal for this project is to establish and implement standardized, consistent set of health terms, definitions, concepts that all stakeholders can use across the health system to realize HIE. And so this is a really exciting project. And you could see here, this is a live website where you can see across many domains what are some of the nationally endorsed standards within Kenya. And the intent is that regardless of how data is captured at the point of care, if you're going to exchange it, as soon as it leaves that point of care system, then it needs to align and be normalized against these nationally endorsed standards. And so if you dive further in, then you're not just seeing the kind of the domains. You can dive into specific codes, and here's an example of diagnostic service, and we can look at specific descriptions and attributes and relationships for a particular code for one of these domains. So, and again, the Kenya project is a really exciting project that is working on projects at all three levels of this maturity implementation milestones, but wanted to provide a few other examples as well. So for digital subscription, I like to think about this project, the Dictionary Management for OpenMRS. This is built on the Open Concept Lab open source product. And there's for OpenMRS, for those that are familiar with that project, it is built on a concept dictionary that ensures all data that is captured is coded, and which means that all data can be structured. It's a significant step in the right direction toward enabling interoperable data. But every OpenMRS implementation gets to use their own concept dictionary, and it's often challenging to implement a governance model across OpenMRS implementations, like in a large deployment where maybe hundreds or thousands of facilities are all using their own OpenMRS instance. So how do you keep all of those dictionaries up to date and in sync? And maybe even more, how could I make sure those dictionaries are built on well-curated content that's available in the world, such as the CL interface terminology? And finally, how could I learn from the community or give back to the community so that others could take advantage of all of the knowledge and expertise that is invested and represented in a concept dictionary? So that's what this model does. And so there's a kind of a sequence here where if you could use OCL as a central platform that's available in the cloud, or you could set up your own instance, and pre-populate that with this best practice content such as CL or others. And then that could be used as a place to collaborate and to centralize governance of your concept dictionary. And then there's a synchronization module called the OpenMRS OCL module that's now packaged with OpenMRS version 3 that lets you import a dictionary that you're managing in OCL into your OpenMRS instance and keep that up to date. And there's also the option to export that dictionary from OCL and to package it up with your as a distribution package, which is a common way to make releases or updates to especially large distributed OpenMRS deployments. And so that you don't require an internet connection just to update your dictionary, or so you could package updates with the clinical forms that are using those new terms. And then you can begin to use that updated dictionary for data capture. And then finally, you can make that dictionary available for public use by making that a public resource in OCL, which lets it be reusable and lets others learn from your work. There's again, I'm trying to make resources available so you can take a deeper dive into all of this. So this digital subscription is a case study provided by MSF and a great blog post here so you can take a look at get deeper on this one. So the final example here is around data exchange. So the Brazil's International Patient Summary or IPS implementation, I think, is an excellent example of this. This was just published in the Oxford Journal. And there's a link here to take a look. There was a tremendous amount of terminology loading and mapping work that had to take place to map Brazil's codes to that were being used in their point of care and many different environments to common IPS value sets. And OCL was the terminology service used to manage those terminologies and mappings, and it powers an IPS viewer that supports real-time lookups and translations. And there's additional links here that you can take a look at, including a link to a recorded presentation at the OpenHIE Terminology Services subcommunity. If you'd like to learn more about this, it's a really exciting project, and they're doing incredible work there in Brazil. So finally, what does this look like when you bring this together into a national implementation? So terminology services can be used at project level. They could be used at a delivery network. They could be used at a hospital or even a facility. There's lots of different uses for terminology services. But what if a country is establishing a national program to provide nationally endorsed terminology as a central resource and to support transactional use? So again, as part of the OpenHIE community, we've been developing a national health data dictionary conceptual framework that describes the different components of an NHDD implementation and begins to provide examples for how a country can pursue this. There's a lot here, and again, there's a link if you'd like to take a deeper look. The key components that have been described, though, are software, the content, the terminology content itself, and then the governance that's built around that. There's a fourth component, which we're referring to as community, because at a national level, it's so critical that a government is engaging at the health system to remain dynamic and responsive to implementation requirements as they're emerging, and to be responsive to the international community and standards as they are updated and new releases are made available. So that is a fourth component that is being incorporated into this now. The next, we are using the OpenHIE Terminology Service meetings as a forum to develop this framework. The next meeting is this Friday. We meet monthly. You're welcome to join, and there are many previous recordings and notes available as well for discussions related to this if you'd like to learn more. The leading examples of this are Kenya's KNHTS that we talked about before, and also the Ethiopia's National Health Data Dictionary project. Okay, so I just walked through quickly a number of examples, and now I'd like to take us through the Open Concept Lab, which is an open source product that is a reference implementation for the OpenHIE terminology service specification that has kind of a unique approach to thinking about this. Not only is it open source, but it's collaborative. It's made to be like the GitHub for terminology, where you don't need to start from scratch. You should be able to start by looking at what is the community doing, how is the community taking advantage of terminology and modeling it for their own use in their projects. And that could be project level data dictionaries like an OpenMRS, or it could be more normative value sets and concept maps or code systems, and the way that they're being mapped to reference vocabularies. So kind of covers the whole spectrum. So Open Concept Lab is, like we mentioned, is an open source terminology management system. It's open source, it's cloud-based, it's community-driven, it's very active in communities of practice like OpenHIE. It's standards-based, it supports some aspects of FHIR R4B and SVCM, and it's also, and importantly, LMIC focused. The mission of the product or project is to preferentially develop features and provide content that are important to projects and LMICs. OCL is recognized as a digital global good. And so we packaged up the product into these two key tools. The first is the terminology service. This is a back-end API-based component that's FHIR enabled. And 100% of the functionality provided by OCL is available at the API. So the term browser is a web-based React client that's built on top of the terminology service that provides an easy user interface to interact with the terminology service. And it actually can also interact with other SVCM enabled tools, meaning if you have a happy FHIR instance, you could connect the term browser product to an OCL terminology service and at the same time to your happy FHIR implementation. And finally, OCL Online is where you can use these tools alongside the global community, and it's already preloaded with a lot of terminology. And like ICD-10 and LOINC, SNOMED GPS, and plus a huge amount of community content where you can learn how others have approached their modeling and implementation projects. So even though we have OCL Online, OCL is an open source product, and it's available in these GitHub repositories. You are free to download it and implement it locally for testing, for production deployment, based on your needs. So a couple quick examples of just, how is it different? What's important about this? And so first of all, it's search based, it's search kind of forward. And because it's a multi-tenant system, search by default looks across the entire community. So if you look for malaria, you're going to find reference vocabulary, you'll find community content, and you can quickly start to hone in on, how have people modeled these concepts and how could we learn to do that locally? And you could find ones that you could reuse so you're not starting from scratch. You have the ability to customize your organizational footprint, so you can make it branded, and you can direct people toward highlighted content that's important to your projects. There's cool features like visualization, so you can visualize relationships and you can navigate these, navigate a hierarchy easily. And there's also side-by-side comparison, so you could take a look at two different models of a particular concept like malaria, but also two different versions of the same concept, so you could see how it's evolved over time. There's a lot more here. These were just really quick things to start with. So OCL does have a fire capabilities. We call this the OCL Fire Core. This was beta launched in 2023. It is still under active development. We encourage people to begin using it, but we do still call it beta because there are some gaps between our current capabilities and the full Fire R4B specification for terminology services that we are continuing to work and address. Everything that you load into OCL is available as Fire or in the OCL API. You don't choose. It's not like you do Fire work and then you do OCL work. It's just any content that you've loaded is available in both. And there's some pretty cool stuff that we've made available, including these canonical URL registries. Because it's a multi-tenant environment, we have to do some special work to ensure that that if I reference LOINC, am I pointing to my locally developed or authored subset of these, this LOINC codes that I'm using for this project, or am I trying to reference the gold standard LOINC that has, all tens of thousands of terms managed by Regenstrief's LOINC team, and so this is a way that you can resolve that and have complete control. We've already talked through some of the key examples, and so won't go into these again. And like I said, this is an open source community of practice. Please visit the website. You can take a look at our roadmap to see kind of where development is headed. There's online chat forums. Our YouTube channel has videos to get you started. And our technical documentation can get you your developer started to, if you want to deploy or start integrating with the REST API. And we do have a lot of community calls, including the monthly OpenHIE terminology services call, where we're very active, but also our weekly architecture developer calls and community calls if you'd like to join and learn some more. So I've covered a tremendous amount, and I just want to thank you for your time and your attention. I've seen a lot of questions in the chat. I'm happy to start going through those, but Alvin and Cha, maybe I can hand it over to you if you'd like to kind of have some other reactions from the group, and could take questions as we have time for it.
Thank you for the presentation, Sir John. Before we proceed with the Q&A, I would like to introduce our reactors for tonight. So our first reactor is Mr. Kizito Mrema, a health information system specialist and a founding member of Tanzania Health Informatics Association, and he will be followed by Mr. Jan Michael Herber, Terminology Asset Management Specialist at the UP Manila Standards and Interoperability Lab.
Hello there. I hope you can all see me right now.
Yes, sir.
Yes. As I was speaking, I'm saying in Tanzania 10 years ago, we laid out a digital health investment roadmap, which pointed out areas to invest in within the health enterprise architecture that we had, or the digital health enterprise architecture. And most of the investments, such as the plant level systems that deal with data from the points of service, like EMRs and community systems, they go direct investment as in resource providers for finance and people and human resources. But for the terminology services, we didn't get any direct investor or resource provider because, as per observation, you do not have a direct relationship or direct outcome based on investment in terminology services. It's like a value-added service, so a service that makes other systems work better. So we didn't have a direct invest in it, and we haven't had a solid implementation of a terminology service in the country. But based on the movement that we are seeing within the OpenHIE community and the implementing community within various areas in Asia, in Africa, in other countries, I think we are leaning towards trying to find resources in any way. Even at the central government, the Ministry of Health is trying to mobilize its resources so that we can have a form of centralized terminology service that provides coding for things like products and services. Because in our case, as of this time, we have already tried to implement siloed implementations of terminology services. We have lab systems that exchange data with other systems. Those ones have adopted to use free versions of Loink. We do have finance systems that use that have adopted World Bank and IMF GFS codes. So we have these siloed implementations that try to provide some basic form of technology services, but we don't have a centralized one because of limited resources, like I said. But I think within the next few years, as we keep on learning from others' implementation, and as we keep on getting this experience that we're getting, I think we're going to start some initial moves of adopting such open source concepts as the OCL and all that, because even in our national EMRs that we are using, some of them are based on open MRS, some of them are proprietary, but they all have this access to integrate with technology services, because in our national integration layer, we are using OpenHIM, which already works with such other systems within the OpenHIA framework. So I'm sure based on this experience that we are getting, we will soon be able to find some resources to allocate towards technology services. But based on just its importance, it's already known countrywide within the health sector that we need to have some sort of standardized technology services that is used across the entire country. And for our settings, it can even be somehow more challenging because of the settings in Tanzania. We do have Tanzania mainland that has its own Ministry of Health, and Zanzibar islands that have their own Ministry of Health. We sometimes need to integrate the data between the two sovereignty nations. So we need some sort of having a standardized coding where we can exchange this information, because even the movement of people between the two united countries needs their data to also be moving from between these countries. So we have a challenge that we have to overcome. And one of the solutions to that challenge is having a technology service that is used across both two ministries. So yeah, we know that we need it, and we are working on ways to implementing that. And as at Tanzania Health Informatics Association, we are trying to work with the bigger African group, ALINA, and others in order to gather as much resources and knowledge as we can in order to build the internal capacity within the country to support technology services implementation. That's my reaction for this meeting. Thank you.
Hi everyone, good day to everyone. So my name is John Michael Herbing, we call me Burr. And as mentioned by Cha earlier, I'm the terminology specialist of the University of the Philippines, Manila Standards and Interoperability Lab. So or UPMC Lab. So UPMC Lab recognizes the need for standardized data and achieve meaningful interoperability using semantic and syntactic standards. So I mentioned semantic and syntactic, and I've observed that semantic or terminology standards are somehow not perceived as important as syntactic or the use of FIRE. So because of this, I really see as a clinician as well, I see the importance of the use of terminology services. But to be honest, at the beginning, it's the use and implementation of a terminology service has been a learning curve, has steep learning curve for me. And but when I saw the reality of having siloed health information systems, having different terms and code sets, internal code sets being used, that's when I really saw the importance of a terminology service. So Jonathan mentioned the use of code translations. I really see the value of terminology services. While there are ways for us to do standardization, like we can impose these codes on different health information system providers, but the reality is that it's not gonna work, or there will be a high resistance on that level of change. And establishing that terminology service is important. So in the Philippines, we've only conducted so far 2 connectathons under UPMC Lab, and only one of them having implementation with terminology services. So admittedly, we're still sort of behind. So I'm seeing the experience, and I'm amazed. And I was wondering, when will Philippines will be at that level later on? And I think we really need to to do more practice or exercises on the use of and implementation of terminology services so that we can learn from one another. So we really need to be exposed to the use of terminology services in general. Thankfully, our organization has partnered with CSIRO, or the Commonwealth Scientific and Industrial Research Organization from Australia, to support capability building on establishing standards. And we, as an organization, are looking forward to work with different AHIM community of interoperability labs around the region and learn from one another. So yeah, and hopefully, based on Kizito and Jonathan's sharing of their experience, we can achieve that level of use of terminology services as well. Over. Thank you.
Yes, thank you, Sir Burr and Sir Kizito, for your reactions and sharings from Asia and Africa. We have actually reached the top of the hour, but I would like to pass the microphone to Dr. Alvin for 1 to 2 questions that we can entertain before we end the session. Dr. Alvin.
Thank you, Chuck. John, so many questions. Some of them are coming from me, but if you have any one or two that you want to address, maybe you can just choose which one and provide your answer, John.
So maybe just a couple quick ones. There are one question about SNOMED CT. Is OCL fully tested to support SNOMED CT and other extensions? So we have done a full load of SNOMED CT in OCL environments, but that does not include the ontology information. So some of the advanced capabilities of SNOMED that make it powerful, make it what it is. So some of the post-coordinated expressions and subsumption capabilities. So OCL does not support those. It supports the content and the relationships in the way that on the basic FHIR capabilities. And so that's the first one. Are there some benchmarking tests done for OCLTS? There are some, and some of those we do have a little bit of that captured in Postman, or like Postman collections that you could then run for your deployment. If you're interested, please do reach out. I see another question here about where to go to learn to start using OCL, and the best place to go is definitely our YouTube channel. And I provided a link of that in the slides. There are some great tutorial and demo videos there to get you started in some of the most common projects for people using OCL. So that's probably about all I can capture in a minute here. So back to you, Alvin.
Okay, thank you, John. And with that, I'd like to thank everyone. But before you all go, maybe we can open your cameras and give a quick smile. Thank you, everyone. Very interesting topic. Manisha, I think at some point when you have experience with snowstorm, it will be your turn.
No problem.
Thank
Yes.
Yes. Thank you, everyone. Good night. Take care. Bye. Thank you, John. Thank you, Burr. Thank you, Kizito. Good to see you all, Niels. Thank you. Bye.